Welcome back to Creation Magazine Live. In this segment, what are we talking about?
We're talking about plants.
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 Okay.
Pulsating plants is the article title, and this is by David Catchpool once again.
And that's his specialty, isn't it?
That's his specialty, yeah. It says here he's worked as a plant physiologist and science educator specializing in tropical agriculture and horticultural.
So pulsating plants, never seen one of them. I don't think, maybe I have.
Well, this is, what part of it is pulsating? We're about to find out here. Pulsating plants. Plants never cease to amaze the researchers who study our planet's greenery. With every new impressive discovery about the complex workings of plants, the more we realize how little we know about them. This is especially so in relation to the roots, which, being underground, have been traditionally more difficult to study than the above-ground parts, the leaves, the stems, and the flowers. However, with improved technology, the mysteries of root growth are slowly coming to light. For example, using sophisticated video imaging techniques, a research team led by the University of Wisconsin botanist Simon Gilroy has been able to view the growth of the delicate extensions of the individual root cells known as root hairs. You got hairs on these roots here. There are literally millions of these elongated, skinny projections covering the plant roots. It's long been realized that root hairs hugely increase the surface area of the plant root systems, thus increasing the volume of the soil from which water and mineral nutrients can be obtained by the plant. But precisely how root hairs form and grow has remained a mystery. To Gilroy and his team's surprise, when they trained their cameras on the hairs, they did not witness the slow, steady lengthening they had expected. Instead, they saw the root hairs undergo rhythmic pulses of growth every 20 seconds or so. That's hence the title of the article.
Right.
Pulsating plants. Further investigation linked the pulses to rapid changes in pH, that's the acidity, alkalinity,
right,
at the root hair tip, and also to the levels of certain reactive chemical compounds. The findings show that plants are not slow or static, but far more complex and sophisticated than imagined. And this is a quote from him: "Plants are actually much more dynamic than you'd think by looking at them just sitting there soaking up the sun," Gilroy says. In fact, plants are responding to cues on timescales of seconds to milliseconds.
Wow.
You can think of plants, again, like he says, as something that just kind of sits there and slowly grows. But I mean, science is cool. we learn more about new things. What's more, as Gilroy explained, unlike animal cells, enlarging plant cells have to contend with the cell wall made of cellulose, which is, weight for weight, stronger than steel. The reinforcing strength of the cellulose stops the cell bursting from the tremendous water pressure, the turgor, inside. But for the tip of the root hair to grow, the cell must somehow make the cell wall there just flexible enough to stretch from the internal pressure without bursting. It must then quickly strengthen the wall directly behind the tip once the extension has occurred. The plant cell has to work out where to make the wall stiff, where to make it loose, to control this so finely that the turgor pressure doesn't absolutely shoot off the end of the cell and kill it, Gilroy says. It's always been a conundrum. How on earth does a plant cell do this?
Right.
Again, Gilroy is speaking here. Gilroy and his colleagues have thought that perhaps the plant cell carefully pumps protons into the cell wall to create a gradient of acidity, resulting in steady elongation of the root hair. But, as already mentioned, they saw pulsating growth, which was indeed mediated by protons, but in a much livelier manner than expected. When the protons flow into the cell wall stretches at the root tip and it lengthens, but the plant cell sucks the protons back out again almost immediately, and the cellulose strands lock in place to strengthen the cell wall again. After a brief pause, the cycle is repeated. Why these growth pulses instead of steady elongation? Gilroy suspects that because the root hair is at such a risk from weakening the wall too much and then bursting, it takes a quick breather to check on things. There's a lot of regulation invested in slowing things down and waiting to see if the cell is okay before going on, he explains. The chemical regulation of these pulses is highly complex, and Gilroy acknowledges that there is much more about it that is still unknown. Everything's coordinated. It's like a dance, he says. with the entire complicated ballet occurring up to 3 times per minute. Just as every great ballet needed a choreographer, so too this entire complicated ballet, as Gilroy just mentioned,
Right.
that's been going on repeatedly in the ground under our feet for years without our even being aware of it, must have been choreographed. The Bible tells us just who that choreographer is, and Psalms 104:14 and 1 Corinthians 3:7 are referenced here at the end of the article. So again, another article on, I mean, who would think of reading a magazine on root hair growth, and yet that there's constant advances made like this in science, where researchers like this Simon Gilroy fellow here are and his team are learning more about the smallest parts of life of a living system. In this case, the little hairs that grow on roots.
Or things that people would consider simple, right? In the evolutionary story, plants, they would have came about first, right? And then, you know, things got more complicated, and finally we get, you know, sea life, and then we get, you know, things that crawl out of the sea, et cetera, and most people know the story. But what we're looking at here again is that so-called simple things aren't simple at all. I mean, if I could come up with a system like that for some reason, I don't know, we needed to develop some kind of device that needed to, you know, probe into the earth or something like that, and I could put a system like that together, I'd probably get a Nobel Prize or something. Well, seriously. I mean,
pretty complex.
Yeah. You know, and so I think that's the thing, because you've got people like atheist Richard Dawkins out there who's saying, no, you know, evolution itself is the designer. You guys look at that and you say, well, that's well designed. But I'm saying as an evolutionist that natural selection itself becomes the designer. We don't need to invoke a creator god or intelligent design or anything like that, because evolution just is going to explain it all.
Right. I mean, these types of systems make sense only if there's a creator.
Right.
If there's something there, if there's God there initially, to put such a complex system in place.
Because it's information based.
Because it's information based, as we've said many times, and there's many articles in Creation Magazine and at creation.com that talk about information.
Yep.
This is one of the biggest problems with biological evolution right now, is how do you get the information?
Right.
Life is based on information, and the article here hinted at it as well.
And it's got a whole system of not only performing something, but then it performs it, and there's some kind of check being made. Okay, did we do it right? Oh, good. We're okay. We regroup, and then we move on. I mean, that's indicative of a system that was designed by an intelligent mind, right? You can just picture, you know, before they evolved this mechanism. So you literally were blowing the ends of you of these, you know.
Yeah,
imagine the plants
that,
these plants that hadn't evolved that yet. They're literally, you know, shooting the ends of their strands off or something like that.
But Dr. Gilroy is saying that that they're not sure why it pauses, right? They
kind of hinted at there might be.
Yeah, maybe there's kind of a check. The cell is checking itself out to see if everything's okay, and then there's another pulse of growth.
Right.
If it just what that the kind of the takeaway thought for me is that here even researchers who are studying this at the cutting edge of this research on these root hairs, they're speculating on things. They don't even know what it's doing, and further research is required.
Right.
It's amazing, like microscopes. If we have something man-made, and you look at it under a microscope, it just gets sloppy. But if you look at something that the Creator made, you can get finer and finer, more and more powerful microscopes, and it's just more and more beautiful and complex.
Right.
Amazing, some of the information there in Creation Magazine and on creation.com.